Hi guys, I'm Shreyas and today we'll be discussing the solutions of the recent code forces around 719, which is div3 one. So let's get started with problem A. Okay, so in problem A we are given a string and we have to determine if all the occurrences of a character are together as a substring or not. So for example, over BAB, so both the occurrences of substring of both the occurrences of B are not together, so it's not a valid one. So we just need to determine if they are together or not. So for that we can just find the first occurrence and the last occurrence of that character, and we can iterate through the first till the last occurrence, and we can just check if everything in between is equal to that character or not. So that's how we do it, and we just print yes or no based on that. So that's our problem A, guys. Okay, so let's start with problem B. Okay, in problem B we are given n, and we need to find the number of numbers between 1 to n which have the same digit in them. So for example, 9 has only 9 in it. So what is the count of that number between 1 to n? Okay, so for this problem the idea is like, so the limit is 10 power 9, so the maximum number of digits would be 9 only, that is 10 power 9 minus 1 would be like 9 times 9. So, and also for any k digit number, the number of such satisfying numbers would only be 9. For example, if it's a 1 digit number, the numbers would be 1, 2, 3 till 9. So they all have unique same digit. If it's a 2 digit number, it will be 11, 22 till 99. So if it's a 9 digit number, again the count only will be 9 times. So the maximum answer will anyways be 81 only. So we can just brute force for it. So in the outer loop we can just check the number of digits. I'm starting with 1 single digit, and in the inner loop we iterate from 1 till 9, and we check if I into j is less than n, and increment the answer. So in the second iteration it becomes 11. So 11 in the sense we are checking for 2 digit numbers. So in the inner loop 11, 22, 33, all those gets satisfies this condition, and answer gets incremented, and then we print it. So that is about problem B. And problem C, so in problem C what we need to do is, we are given integers, like we have integers from 1 till n square, and we need to arrange them in a matrix of n cross n such that there is no adjacent cell whose difference is equal to 1, or the absolute difference is equal to 1. So there should not be any such cell where there is like adjacent cell which has absolute difference equal to 1. So the way I followed, one of the simplest approaches to solve this problem is to first arrange all the odd numbers and then arrange all the even numbers. It would work as well, but during the contest I just reverse the alternating columns. For example, I start with column number 2, I reverse that entire column and then go to column number 4, I do the same thing there again. So I did that for alternating columns, and then so that part of code is over here, and then if the number of rows is odd, right, even if we reverse the column, the element stays in the same position. So for that we need to alternatingly reverse the row elements only. So I did that alternating reversing of row elements in this code, and that's it. And this logic cannot handle for n is equal to 3, so that there's an edge case, and n is equal to is an edge case for all of the approaches as well. So that is about problem C. And next, problem D. Okay, so in problem D we need to find the count of pairs such that this condition is satisfied. Okay, so the trick over here is to rewrite this into aj minus j equal to ai minus I. Over here, aj minus j equal to aj ai minus I. So find the elements which satisfy this condition. So for that I am subtracting the index from the number, and I am incrementing the count of such numbers. So if there are n such numbers with a similar value, then the number of ways to select a pair from n such numbers is nc2. So nc2 is like n into n minus 1 by 2. X dot ss, ss in the sense is second, so it's short form of second. So it gives the count of a particular value. So this is just summation of nc2 over all the values present in the map. So that is the answer for D. And next for problem E. Okay, in problem E we are given a string consisting of dots and stars, and our job is to bring all the stars together. And the cost of moving one star to the right or the left is 1 unit, and we need to minimize the cost. Okay, so for this problem I used a DP approach, where so initially we need to handle the edge cases. Suppose if there is no star, or suppose if there is no dot, then there is no point, then it's already sorted, right? It's already in the right state, so the cost is 0. Otherwise I am just maintaining two DP arrays, DP forward and DP backward. So what DP forward means is the DP forward at any position I is the cost of bringing all the stars from the previous positions to the position I. For example, if the DP forward of this position, this dot at the end, would be the cost of bringing the stars from all the previous position to this position. So in this second line, line number 151, two stars are brought at the position and they end at that position. The collection ends at that position. So the cost of bringing them from the previous position to this position. And DP backward is the cost of bringing the stars from the greater positions to the current position. For example, DP backward of position number 2 would be the cost of bringing these two stars which are ahead of it to the back, and they must be together as well. Okay, so after we calculate DP forward and DP backward at any position I, we can just check the cost would be DP forward of I minus 1 plus DP backward of I plus 1. So we are assured that DP forward of I minus 1 and DP backward of I plus 1 would always be a collection of stars. They are together only, and anyways the current ith position also star, so all the stars are together now. And in this part of the code I have calculated DP values. So the idea over here is, like, if you want to move one position to the right, the cost would be the count of the stars which are there to the left. So if there are like k stars, and if you want to move to the right, and if you want to move them to 1 unit right, all of them, then the cost also would be k right. So DP of I would be whatever the cost of I minus 1 position plus the current number of stars which are processed. And if we meet a star, we increase the count of stars, and so that is how we do it for both the backward and the forward, and we just update the answer based on the DP I minus 1 and DP I plus 1. And there are some edge cases, like if it's the 0th position, then there is no I minus 1, or if this n minus 1th position, there is no I plus 1. So handling those basic edge cases and doing the normal thing would give us the answer. So that's about problem E. Okay, so let's start with problem F. Okay, so F1 and F2 I'll be explaining together only. So because there's only one change, that is t is equal to 1 in F1 and t can be more than 1 in F2. And yeah, so the problem says that like they are given an array, but the array is hidden from us, and we need to find the kth position, the position of the kth 0 in the array, and the array consists of only zeros and ones. So to find out the kth position, we can make some requests. So like we can request L, we can make a request in the form of L comma R, L and R, and the interactor will provide us with the sum of elements from L and R, which is nothing but the number of ones as well, as the array contains only 0 and 1. Yeah. So we can only make such queries, and then we need to determine the position of the kth 0, and it's always guaranteed that the array contains k zeros at least. Okay, so one thing what I observed, like I almost solved this in the contest with this one observation, that they are given only 20 requests. So we need to take care of observe the constants. Over here, queries is number of queries is 20, and n is like 2 into 10 power 5. So if you take the log of log of n base 2, it will be like 17 point something, or at least 18, round it off to 18. So and 18 is less than 20, so it's an indication to use binary search or something, some technique of that, binary search or a Fenwick tree or something like that. So because log n is like less than 20 only, so if we use a binary search, we can, within 20 queries, we can find the answer. It's like starting from the entire segment, we just go into like either one of left or right, and then ultimately we can just get the correct position of the kth 0. Okay, so let me explain the code only. So yeah, so initially we don't know the position, so we are keeping like 1, it could be anywhere between 1 and n, and since t is 1, we are just doing one iteration of the binary search. So we are calculating the mid, and we are querying with the mid value L and M, and the interactor will provide us with the number of ones in that range. So we get the number of ones in that range, and from the number of ones we can calculate the number of zeros by subtracting it with the length of the subarray, length of that range. And now what if the zeros, the number of zeros is less than k? So that means like from L to M, the number of zeros is less than k, so the kth 0 must lie beyond M, right? So that's the reason we are incrementing M. Otherwise we just decrement the n to M. Also, like once we are incrementing the L to M plus 1, we have to subtract zeros from k. This step is very important actually. So the reason for doing that is, in the next iteration we are handling M plus 1 till the new mid value, right? We are not handling these things. We are not handling L to M. We are handling the new mid value, new subarray. So over there we should not consider the already processed zeros. So these zeros belong to this part. They do not belong to this part. So k should not have these zeros while handling this part. So that's the reason we are subtracting it for the next iteration. So in that way, within 20 queries we can easily obtain the answer, since log n is less than 20. Now the extra thing in the F2 problem is that there are like t times the binary search has to be done, and each time we get a new k value. So here we are inputting the k value over here, and then so there are like, at the max we can do like 6 into 10. So in F2 the number of queries is more than 20, so we can make like 6 into 10 power 4 queries. Like we can just use the previous approach itself without any modifications, but we will get query limit exceeded error, like because for each time we are doing a binary search, we are making the same queries, right? So we will get query limit exceeded, and so the way to resolve it is, if we have already processed a query, we shouldn't do it again. We shouldn't query the that range again. So that thing we can, if we can cache the queries in a map or something, and if we again visit the same limits, we can just obtain it from the map only. So here that's the thing we are doing. If it's not there in the map, then query and do the same thing. But if it's there in the map, then just directly get it from the map. Don't do it once again. Don't query once again. And so that's the only thing. We are just caching it. And one more thing is, there is a instruction in the question that once we find out the right position, the 0 in that position turns out to be 1, like it changes to 1, right? So since we have cached the ranges for all, right, we have to update in all the ranges, like wherever this position is involved, whatever ranges has this position involved, we need to update the number of zeros in that range as well. So for that we are using the update function. So initially I am passing 1 and n because the position will definitely lie between 1 and n, right? So and then decrease the count in that range, and if the position is less than mid, then go to the left part and update it, otherwise go to the right part and update it. So the reason for decreasing it is because it turns out to be 1 after each query, so according to the instruction in the question itself. So those were the two extra things, caching the ranges, answer for the ranges, and also updating the value in the suitable ranges. So only those two things would suffice for this problem, and it's a pretty straightforward problem actually. Okay guys, so let's start with the final question, that is problem number G. Okay, so this thing we'll explain with the help of diagram. So we are given an n cross m grid, and then we are starting from 0, 0 and 1, 1, and we need to go to n, m. So what is the minimum cost to to go from 0, 0 to n, m? That is the question. And there are three types of values a cell can hold: 0, -1, and a positive integer. 0 means we can access, the cell is accessible. -1 means the cell is inaccessible. And if there is a positive integer, it means the cell is accessible. Plus, from such a cell we can go to any other cell which also has a positive integer value. For example, 16 can go to 3, 16 can go to 1, because those two cells have positive integer values, and those such type of cells are known as portals. Okay, so with these constraints we need to find the minimum cost. So there is an important observation that we need to make over here, that we should not be using more than 2 portals at any time. The reason being, suppose if we are going from 16 to 3 and then 3 to 1, instead we can directly go from 16 to 1. And sorry, I forgot to explain the cost. So we need to input the cost, which is the cost of traveling between accessible cells, and the cost of traveling between the portals is the sum of values in those two cells. So if we travel from 16 to 3 and then 3 to 1, the sum would be 16 plus 3 and then 3 plus 1, that would be like 24 or 23. Yeah, but if we directly go from 16 to 1, it would be only 17. So only using we need to use maximum of only 2 portals, or we may not use it as well, but that depends on the later conditions, but maximum of only 2 portals. And okay, so that is the observation number 1, and the remaining thing is, like, how do we identify the suitable portals? Like, how do we determine if 16 and 1 is the best are the best portals to be selected? So for that we need to find the cost of reaching this cell from the start, and the cost of traveling from the second portal till the end. So if we have those costs, then the total cost of start to the end would be start to the first portal to the second portal, and then second portal to the end. So so the requirement is now to find the start time and the end time for all the vertices. So first we have inputted the array, the grid, n cross n grid, and forward is the cost of forward and backward arrays are the cost of getting to a particular cell from the start, and backward is the cost of moving from a particular cell to the end. So those two values we have to calculate, and initially forward of 0 comma 0 is 0 because it's the starting position, and the backward of n minus 1 is m minus 1 is the 0 as well because it's the last position. And for calculating the cost we are making use of a BFS. So this is just a normal BFS where I'm using a queue, and the idea is from each vertex I'm traveling to the 4 adjacent vertices and adding the cost. So while traveling I'm maintaining a visited array and a check to verify whether the cell is accessible or not. So it should not be equal to -1, and it should not be already visited. So by BFS we can easily calculate the cost of traveling for each cell. So we have this filled now. So backward and forward arrays are filled, and initially we can initialize the answer to forward of n minus 1 m minus 1. So that is equal to the cost of going from 0 to comma 0 to n minus 1 comma m minus 1. So that is the cost without using any portals. Now to select the most optimal portals, if any, we are executing this loop where we are considering only those cells which have portals. So this line ensures that there are cells only which have portals, and so as explained in the diagram we need to find the start cost and the end cost. So that thing we are executing in this line. So minimum of start cost comma forward of ij plus the value of that cell, and the backward of ij plus value of that cell. So we are individually minimizing the start cost and the end cost, and the answer would be start cost plus end cost, like minimum of answer comma start cost plus end cost. Like note that we are including the values of the portals in the start cost and the end cost itself. We are not considering it separately, so that's included, and then we get the final answer. So these were the problem, guys. So like it's one of my so I'm new to this kind of doing streams and doing recordings. So please, if there are any improvements or suggestions, please drop them in the comments below, and thanks for watching, guys. So I will be optimizing it further like in the next videos if there are any improvements. So thanks for watching the video, guys.